You now say this is not only an alien spaceship, but it's nuclear powered? Why are you saying that?
On October 2nd, 2025, an amateur astronomer captured what appears to be the first image of 3I/ATLAS, the third interstellar object ever found, from Mars. Just hours later, NASA's data feeds went dark. Coincidence or cover-up? This is the story of a cosmic leak that beat official science to the punch. On July 1st, 2025, a telescope in northern Chile caught something strange. The ATLAS survey, part of NASA's early warning system for near-Earth objects, flagged a fast-moving point of light that didn't match any known object. Within hours, orbit calculations revealed something shocking. This wasn't from around here. It was traveling on a hyperbolic trajectory, a path that begins far beyond the solar system and ends right back out into deep space. That's when the name dropped, 3I/ATLAS. The 3I means it's just the third known interstellar object in history, after Oumuamua in 2017 and Comet Borisov in 2019. Its full name, C/2025 N1ATLAS, follows standard naming rules for comets, but the interstellar tag gives it a rare, almost mythical status. What's even more interesting is that astronomers later found earlier images of it hiding in plain sight. Data from other sky surveys, TESS-ZTF, had actually caught glimpses of 3I Atlas before July, but no one had noticed at the time. It was moving fast and faint, blending in with the background. The speed told its own story, 60 kilometers per second and climbing. Too fast to be held by the sun's gravity, too clean a path to be a local wanderer. This object had crossed light years before brushing our solar system. For astronomers, it was both exciting and humbling. As one planetary scientist put it, every interstellar object is a letter from another star, but we don't know what language it's written in. The detection raised urgent questions. What is it made of? Where did it come from? Could it be something other than a comet? A probe, even? The scientific community moved quickly. Observatories across the globe were redirected. Spectrometers, tracking tools, and predictive models all locked in on this rare traveler. But just as this surge of interest unfolded, something unexpected happened. The first image seen by the public didn't come from a major observatory. It came from Mars, and from an unlikely source. Almost at the same time, NASA's public-facing systems went dark. Data streams, tracking feeds, and live updates suddenly stopped. The reason given was a government shutdown. Routine, bureaucratic, and frustrating. But the coincidence was hard to ignore. Just as an interstellar object made its closest pass to Mars, the official observation channels went silent. This timing triggered speculation. Was it simply bad luck, or was sensitive information being withheld? The public had seen the object, and yet the institutions built to study it were now mute. The contrast couldn't be sharper. A lone amateur shared the first sighting, while the world's largest space agency went offline. It wasn't just about the image. It was about access, trust, and transparency. What else had the rovers seen? Were the Mars orbiters also recording? If so, when would those images come out? This sudden silence amplified the mystery. As one astronomer tweeted, "When the sky talks, someone should be listening." With Earth's view of 3I Atlas fading, attention turned to Mars, now the best vantage point for tracking this alien visitor. What came next was the most crucial moment in the entire event, a close pass to Mars and the chance to observe the object up close, if anyone was still watching. On October 3rd, 2025, 3I Atlas made its closest approach to Mars, passing near the red planet before slipping behind the sun from Earth's point of view. This wasn't just a scenic flyby, it was a crucial observational window. With Earth blinded by solar glare, Mars became the only platform still able to see the comet. This rare alignment turned Mars orbiters and surface rovers into frontline observers. Instruments aboard Mars Reconnaissance Orbiter, ExoMars Trace Gas Orbiter, and Mars Express were rapidly recalibrated. Cameras and spectrometers were pointed toward the thin streak in space, hoping to catch details Earth-based telescopes could not. Even systems like CASSIS were reportedly used to image the object in multiple wavelengths. Scientists hoped to spot gas emissions, trace out the coma, the surrounding cloud of dust and gas, and track the behavior of its developing tail. Spectral data would hint at its composition: water, carbon dioxide, or even heavier elements. There were whispers that Hubble-class images were taken, but they remain unreleased, deepening the silence that followed the earlier NASA blackout. This Mars encounter matters not just for images, but for what it symbolizes, a moment when the focus of humanity's cosmic attention shifted away from Earth. With the next leg of the journey underway, the next big question centered around the body's true size and internal structure, something scientists now scrambled to measure. Estimating the size of 3I Atlas was like spotting a pebble in a fog, but its motion revealed a lot. Harvard Center for Astrophysics detected very weak, non-gravitational accelerations, suggesting minimal outgassing and a massive, stable core. Their estimate? Over 33 billion tons, with a diameter around 5 kilometers. Hubble confirmed this, showing a hard cap near 5.6 kilometers, though some media mistakenly reported 10 to 20 kilometers, likely confusing the surrounding coma with the solid body. Scientists insist it's not the biggest, but it's the heaviest interstellar object ever recorded. For comparison, Comet Borisov was about 1 kilometer wide, and Oumuamua likely smaller. 3I Atlas is denser, more compact, and notably stable. No tumbling, no rapid brightness shifts. Its motion is steady, its surface possibly hardened by deep space exposure. One planetary scientist remarked, "It's not just big, it's built like something that expects to last a long, long time." With mass and motion this unusual, attention shifted to what 3I Atlas was actually doing near the Sun, how it reacted, what it released, and what those signals might tell us. 3I Atlas didn't behave like a typical comet. Most light up near the Sun with bright dust tails and visible outbursts. But through late September, this one remained quiet. Images showed only a faint coma, an ionized haze of gas and fine dust, with no clear dust tail. Then, around September 25th, a coronal mass ejection, CME, from the Sun swept through. Scientists think it energized the coma. Soon after, Gemini South confirmed a growing tail. The comet had awakened, slowly, silently. NASA's SphereX telescope picked up a vast CO2 cloud, stretching 348,000 kilometers. More surprisingly, it may be shedding 40 kilograms of water per second, at 2.9 astronomical units, well beyond Mars where most comets remain frozen. This confirms what early models hinted at. It came from interstellar space and it's leaving the same way. That alone makes it historic, but the details are more curious. Scientists noticed slight deviations from the predicted course, not wild swings but small nudges, likely caused by outgassing as gases escape from the surface. Here's the strange part. The acceleration is weaker than expected. For something this big, it should be more affected. Combined with its high mass and minimal spin, the result is a motion that's smooth, stable, and hard to disrupt. Unlike Oumuamua, which tumbled, or Borisov, which flared, 3I Atlas is quiet, almost deliberate. Its exit path cuts sharply through the outer solar system, not influenced by any planet or body. It doesn't follow anything familiar, it simply moves on. Some astronomers speculate on its Mars flyby, asking whether this close pass is random or patterned. A NASA analyst put it simply, it's not about the path, it's about the signature. And right now, those forces are quieter than they should be. That silence of motion and mechanics leaves the door open. Is this just an unusually heavy, quiet comet? Or is it something else entirely, slipping past us while we watch and wonder? Despite the internet buzz, most astronomers agree 3I Atlas is likely a natural interstellar comet. That's the consensus across NASA, SETI, and major research groups. Its shape, brightness, and activity, while unusual, can be explained by natural physics, even if some parts are harder to pin down. Its hyperbolic trajectory confirms it's not bound to the Sun. Its non-gravitational accelerations could be explained by slow, deep outgassing. Its mass might be high, but not impossibly so. The chemical signatures, like the carbon dioxide coma and possible water emissions, are rare, but not unknown. Comets are messy, chaotic, and often defy models. This is why the standard approach remains measured. As one planetary scientist from JPL said, "It's weird, but weird doesn't mean artificial." That single sentence sums up the attitude in most research halls. Eyes open, but feet on the ground. To suggest something is non-natural, like a probe or alien craft, the burden of proof is enormous. You'd need to see deliberate energy emissions, controlled course corrections, and that's where the next chapter picks up. The speculative edge, where scientific method meets the human instinct to wonder. A few researchers aren't satisfied with standard models. They're asking harder questions and offering bolder ideas. Among them is Avi Loeb, the astrophysicist known for pushing the envelope. He's proposed that 3I Atlas might be a technological relic, citing its large mass, low outgassing force, and unusual spectral data. One odd detail? The detection of nickel without iron, a chemical imbalance that's hard to explain through standard comet formation. Another? Its activity far from the Sun, releasing water and carbon dioxide when it should still be dormant. These aren't proofs, but they're signals worth investigating. Then there's the planet seed hypothesis from astrophysicist Suzanne Fnur. Her idea? 3I-ATLAS could be a core fragment from an ancient planetary system, flung into space to seed young star systems with material needed to build planets, a cosmic starter kit, drifting between stars. More fringe thinkers have suggested silent probes, alien technology designed to drift undetected until triggered. A passive device, maybe ancient, maybe still functional, but again, no direct signals, no power sources, no course changes, just theory for now. As a SETI spokesperson put it, if this were a probe, it's the quietest one imaginable. The speculation isn't without value. It sharpens the questions. What would real evidence look like? What would separate a natural object from an engineered one? For now, 3I-ATLAS sits in that in-between space, too quiet for certainty, too strange for comfort. With perihelion approaching and more eyes turning its way, we may soon learn whether this visitor is simply a deep space wanderer or something far more provocative. Whether 3I-ATLAS is natural or artificial, the implications are huge. If it's just a comet, it's still the most massive interstellar object we've ever tracked, offering a rare chance to study extrasolar chemistry up close. But if it's not, if even one anomaly proves unexplainable, it could mean we've seen our first brush with non-terrestrial technology. That potential raises the stakes for transparency. The NASA Black. Then there's the scientific puzzle. If interstellar objects like 3I-ATLAS are common, why have we only found 3 in decades? Are we missing hundreds more? Or is there something unique about the ones that do show up? Their size, shape, behavior? This one, after all, is larger, heavier, and far more stable than its predecessors. It also hints at a deeper possibility. These aren't just random fragments. Maybe objects like 3I-ATLAS are deliberate visitors. Maybe they carry organic materials, volatile compounds, or even planetary seeds from long-dead systems. It's a big leap, but not without precedent. Nature has a habit of using comets to deliver things that change worlds. The key date now is October 30th, 2025. The perihelion, 3I-ATLAS will pass within 1.4 astronomical units of the Sun, briefly dipping closer than Mars. From there, it begins its long exit back into interstellar space, never coming closer than 1.8 astronomical units to Earth, well out of range for most ground-based telescopes. This makes every observation count. Mars orbiters, ESA's JUICE mission, and possibly future intercept proposals are racing against time to gather data. Scientists are watching for changes in brightness, radio signals, chemical signatures, or course deviations, any sign that something unusual is happening. So far, there's no smoking gun, but the object remains quietly anomalous. A comet that behaves too slowly, a mass that's hard to reconcile, a timing that feels almost scripted. And so we're left with a set of final questions. Was the amateur image really the first, or just the first shared? Did the NASA blackout hide something, or was it a tragic coincidence? What would it truly take to prove 3I-ATLAS isn't natural? And most of all, what do visitors like this teach us about our place in a galaxy full of moving things? Maybe it's just a rock from another star. Maybe it's more. But either way, it reminds us, we're not alone in space, even if we are still alone in knowing. 3I-ATLAS is leaving, but the questions remain. Did an amateur truly catch the first glimpse?